everybody. Welcome to NTWC Plus. It's the 9th day of July. This is season 6, episode 6 of NTWC Plus. Glad to have you along today as we work our way into the 2025 hurricane season. Unfortunately, relatively quiet as we speak. Bill's going to go in depth into that. But let's thank our sponsors who make these shows a reality week in and week out. First of all, because we appreciate all they do for us. USAA, the South Padre Island Convention and Visitors Bureau, the Weather Company, Weather Boy, and LiveView. All the sponsors who are here each and every week and have been for years, and we appreciate each and every one of them. Our regular hosts are with us this morning. Let's say good morning to Dr. Hal Needham. Good morning, Hal.
Good morning, Tim. It's a beautiful morning. I have increased my elevation by 1,000. Normally joining you guys from 9 feet in Galveston. Today I'm at 9,000 feet in Colorado. So a little bit of a difference, but I'm so excited for today's program.
Where up in the mountains of Colorado are you today?
Kind of southwest of Denver, a place called Bailey. So up high, and it's been really interesting. Hey, a quick weather factoid. This will blow your mind. I went to buy some chicken breasts when I got here, and they all look bloated. I thought, oh my gosh, they're bacteria. And then I got here to the house, and the chips look bloated, and the Reese's cup looked bloated. And I realized it's air pressure. These things were packed at low elevation, getting up here to 9,000 feet, less pressure pushing in on them. It's not bacteria in the chicken, it's air pressure. Cool little meteorology factoid that I came across this week.
The tip of the day, that can of Pringles you drove up there with exploded when you got to the top of the mountain, right?
You got it. I could tell you've been at high elevation before.
Did your champagne bottle explode?
Not yet. I always wait till right after NTWC to open it. So, I'll find out in about an hour.
So glad to have you along, Hal, this morning. You're about 20 miles from where I was last week at this time. Bill Reed, slightly lower elevation, slightly higher dew point, but not much. Northern New Mexico somewhere, Bill?
Yeah, I'm in lovely Chimayo, New Mexico. We're about 28 miles north of the plaza in Santa Fe at 6,500 feet. And high yesterday was 95, low overnight was 58, dew point 33.
Dew point, so I get the dew point award for the highest dew point that usually you guys get. It's mine today at 72.
We got a bird bath outside, and we have to fill it every day. That's how fast it evaporates here.
Wow.
Definitely dry country. We had good rain on Friday and Saturday, but you wouldn't know it. The ground's hard as a brick again.
Now, Bill, you're on the other side of the state from what we're seeing happening in Ruidoso, right? You're a long way from that, but you're seeing it. You're hearing about it, of course, because you're in the same TV market, basically.
Yeah. There was, if you just looked at a quick glance at satellite and radar, you would have moved on because it was just a relatively small cell. It didn't look. It looked like pretty good rain, but it wasn't an eye grabber, so to speak, when it formed over there, but. Dumped 2 to 4 inches of rain in probably an hour and a half at the most. And it landed right over the slopes that burned last year. And when you have burn scars, it leads to mudslides and flash floods a lot easier than when there's vegetation covering it and the rain falls on it.
It's quite a situation following what happened in Texas over the weekend, which we'll talk more about a little bit later in the program, because we're going to get into that after you do your tropical update about midway through the show, I think. So let's hold off on that. And Hal, we'll get your GeoTrek update coming up in a little bit. Our guest today is Joe Cioni, and Bill, I think you've got the intro, so let's get to that. And again, we're going to talk about the elephant in the room a little later on. That, of course, is the situation in Texas, but we'll get to that. But let's get to our program first. So, Bill, take it away.
Yeah, okay. Well, Joe is a longtime guest with National Tropical Weather Conference, both on our online version that we do all summer and at our annual meeting down in South Padre Island. And the reason we like to have Joe on there is the fine research work he has done to advance the forecasting of tropical cyclones. The bio reads, Joe is a veteran hurricane scientist with NOAA specializing in tropical cyclone dynamics and airborne meteorology. As a key researcher with the Hurricane Research Division, he's flown directly into storms aboard NOAA's P3 hurricane hunters to gather critical data to improve forecasting. His expertise spans high-resolution observations, storm structure analysis, and model development. Joe's work plays a vital role in advancing our understanding of hurricane intensity and protecting lives through better warning systems, all of which are key topics this time of year. Joe, welcome aboard.
Yeah, thanks for having me. I really appreciate you bringing me on here, and very timely as the season's starting to spin up. And yeah, as far as the elephant in the room, I was just watching some of the confirmation hearings and with Neil Jacobs, who's a friend and colleague of mine for many years, and that's pretty much what they're talking about right now. But happy to give you the latest and greatest on the emerging technology that we're developing and testing at NOAA and with our partners to improve forecasts and to really help people get out of harm's way, which is obviously NOAA's main goal.
Yes, it is. Anything new from coming out of your work this year that you were working on since we last chatted a year ago?
Yeah, I don't want to burn up your entire hour though, so I'll try to keep it brief. We are doing quite a bit. My title, I'm not big on titles, but I'm the lead meteorologist for emerging technologies. And basically what that means is I am, and our team is looking at anything and everything new that can improve our understanding and ultimately give us better forecasts. And right now, we are concentrating on a couple of drone systems, both of them flying low altitude. So the P3 hurricane hunters that we have been flying for decades now, are able to deploy this small drone that we have from Black Swift. I'm out in Colorado, by the way, too, so I'm familiar with those.
We should all get together and have lunch together after this.
Yeah. So, and that company is Black Swift is out here. I'm out in Boulder, Colorado. So is Black Swift, and they have a 3-pound drone. Yes, 3 pounds, and this thing can survive extreme winds. In fact, we measured 209 knots at 500 meters in Hurricane Milton, Category 5 last year. Set other Guinness Book records, and Guinness actually called us. So we had set endurance records for over an hour and a half. The wind speed record, which, unless DARPA is doing things we're not aware of, probably is an interplanetary record that for a small drone of 209 knots. And also range between the P3 and the drone itself, which we just did some testing. It's 215 nautical miles, which is incredible. When we first started these tests, it was about 5 miles. So we're testing this drone that flew in Ernesto, Milton, Helene, and Francine last year. And we're building up for this year and getting ready to go and getting more duration, hopefully being able to sample where the P3 can't go, right? So the P3 can stay at about 8,000 to 12,000 feet, but that's not where all the action is. It's down below that into the boundary layer where we all live. No one lives at 8,000 feet. So we want to get winds and structure in the eye wall and do eye wall orbits, things again that the P3 and other systems can't do. So these are critical data that it's not really replacing it, it's new data. We're getting data that we wouldn't get otherwise. So we want to improve the models, both the AI models and the physical models, by providing training data, which is something that we're working on as well. And also to improve the physics of the models and also improve situational awareness, something that Bill is quite knowledgeable about at the Hurricane Center, where we can give them, that closer to that max wind, right? The Hurricane Center doesn't want the average wind, it wants the max wind. So if you're only measuring in a couple of points, it's hard to get that max. You can get the max for the few points you're observing, but now that we're carving out that whole eye wall at different altitudes, the likelihood of getting stronger winds is much higher, which helps for situational awareness, the short-term forecasts, and also for the storm surge modeling too. And interestingly, I'll add this too, it helps with track. I wasn't expecting that, but since we're flying in the eye and flying at low altitudes, when the models look at these in retrospective studies, they say, oh, wait a minute, we thought the center was here. It's actually not. It's about 10, 15 miles away. And that may sound trivial, but not if you're in a county that was maybe not in the bullseye and now is because of this move track, or vice versa. Now we don't have to evacuate one of the counties because you can save a lot of money. So I'll stick with the boundary. There's actually more stuff we're doing, and maybe in another question, I don't want to dominate here with all this talking. There's actually quite a bit more we're doing with this emerging technologies work. But for now, those are the two. The main one we're looking at. We have other platforms that are using things like Starlink and going from land instead of departing from the P3. And I can get into that, and next generation dropsondes that can swarm and all sorts of cool stuff.
Wow. Yeah, I would guess one of the other beauties of the extended range for getting the data from the P3, it doesn't have to alter its other track and mission interests that they're trying to do while that's going on.
100%. And people, when they hear the biggest advancement, we've been working on this platform for 7 years. So there was a lot of early times where we had one success and two failures. People say, and you had that for a few years, but what are you doing? Why are we doing this? You're doing this because lessons learned, and we build on it. When we were first doing this in 2019 or so with this platform, we had 5 miles of range. That exactly what you just said, Bill. The P3 had a babysit, so we would come out and it has to hang around so that it can communicate. But now at 215 nautical miles, the P3 can do its own thing, can do its patterns, not have to worry about if the drone can send the data back to the P3 because it relays to the P3, and we get that data, I should mention, in real time to the Hurricane Center, and not just to the Hurricane Center, we get it into AWIPS. And not just the AWIPS clouds, into AWIPS operational. All these steps, your viewers may not realize, take years to come through and to make sure that it gets to where it needs to go. So with the P3 now doing mostly operational tasking, so what that means is the Hurricane Center and the EMC, the modeling center, task the P3s, say, hey, look, a storm's coming, go out there and get some data for us, for operational standpoints. When they're not doing it, we can do research, right? So we can do these other missions that are not operationally oriented. Of course, we still give the data to the centers, but we can do some interesting things. 10 years ago, I've been around a while, and 10 years ago, maybe 40% of the missions were research. Today, they're about 10%. So there's reasons for that, and I can dive into that later if you want to know why. But bottom line is, it was imperative that we got these drones to the point where they didn't have to be babysit anymore, because now we can run them in operational missions. And we did last year for the first time. Before that, we couldn't do it, which meant that we really couldn't do these drone missions and get the data where it needs to go. But now, due to this engineering leap that we have, we can do that. And it makes it a lot easier for us to operate.
Yeah, it's kind of fascinating. You were losing 2 for every one that succeeded. You were kind of doing an Elon Musk style of development. Proof of concept.
Yeah, it's interesting you bring up Elon. Because Elon actually reached out to us, or his group did, through SpaceX. So that's a good segue, Bill. We are testing something called the Dragoon Coriolis. The drone I just told you that is dropped from the P3 is called the S0, and it's about 90 minutes, maybe two hours this year. But we transport in, so the P3 acts like a bus, gets us in to the storm. We don't have to transit it. We have this other one that we're testing. It's called the Dragoon Coriolis, has 20 hours of duration. And we did some testing last month. So this is fresh off the press, where we did some tests that we were able to go from Southwest Florida near Fort Myers, Pine Island to be exact. And we would transit into a warning area offshore, which is controlled by the Air Force. The FAA, for once, gave us clearance, which, again, is a new thing. We had a hard time getting clearance for flying beyond visual line of sight, basically flying the drone without someone chasing it or watching it, which is a first. So we had this small drone, this Coriolis, about 30 pounds. The S0 is about 3 pounds. Remember, so they're still small, but this is an order of magnitude bigger. And this was the first time, to our knowledge, and it was confirmed by Starlink, which is run by SpaceX, which of course Elon owns. And we used Starlink on this 30-pound drone to go out and communicate with the P3 that met us out in this warning area. And we took data and we compared data. But so it was a test fly. No hurricanes, obviously, this time of year right now. But it was a pioneering flight that we showed that Starlink, which you can have streaming data, we can send back videos, we can send back all sorts of crazy things, and any of the data that we get. And it doesn't have to interact with the P3. We did the P3 here to just test drop-ons to compare the data. But in a situation where this could fly out to a hurricane in the Gulf, do its own thing, independent of having a crewed aircraft out there. So that's a game changer. There are still issues we have to work through. We have to coordinate with the hurricane hunters as they're out there. Right now, we're only allowed to fly 2 drones at once due to due to the NHOP, which is the National Hurricane Operational Plan. But these are sort of regulatory hurdles we think we can get past soon.
Yeah, you're flying them below any altitude. That if one of your planes is down at that altitude, you better be putting out a mayday.
Yes. Yeah, they have the NOTAMs where when you have a hurricane out there, there's like a 200-mile, hey, if you're going to don't fly here, commercial airport. We don't usually have any problems because commercial aircraft don't want to go through a hurricane, and they'll steer around that. So we usually don't have any problems with that. But yeah, we're under that WRA, I think is what it's specifically known as, the weather reconnaissance area.
Now the big one that can go 20 hours, is that retrievable? Can you run your mission, come back and reload and do it again?
Great question. So it is retrievable in the sense that for the tests we did bring it back. But you have to think of it this way. If it flies out 6, 7, 8 hours to get to a storm, which it might, because it only goes about 60 miles an hour, let's say 6 or 7 hours, and you have 20 hours, you only have, if you have to come back, you're basically trading the hours back for flying more in the storm. So we've spent a lot of time on reducing the cost and increasing the duration so that our concept of operation, our default one, is actually not to come back and to spend 14, 15 hours in the storm collecting data at all different altitudes, all different parts, rain bands, everywhere. Sea surface temperature can be measured, so the upper ocean, we can measure pressure, temperature, winds, humidity, eventually three-dimensional winds with a turbulence probe. And I should mention, which good segue for later, we have a replacement for sondes, not a replacement. I get in trouble when I say that. An enhancement for the existing legacy sondes. Everyone loves sondes, but these sondes weigh a half an ounce and can be swarmed at 50 at once. They're called stream sondes. A company from Finland, which also happens to make the drop sonde as well. Two companies are dominating that market, so they can drop that too. So right now, build a ConOp is to stay in the storm, but we could work on a ConOp to bring it back. It's harder though, because now you're traversing back. It's also labor intensive. Now the team has to make sure it comes back. It causes a lot of problems.
Yeah, I can see all kinds of advantages for that. When I was director, we were always getting pressed by our Eastern Caribbean colleagues for going farther and farther out with the plane, and it was the exact same problem. You reach a point where you can only make one pass and come home. Is that really cost effective in helping you forecast? Now, maybe you could pre-season once these become operational, so to speak, deploy them to like Barbados and St. Croix, so you can hit these storms that are otherwise out of range from the P3s and C-130s.
100%. I think that we will have the crewed aircraft for quite some time. How long? Who knows? But, in 100 years, probably not 50, probably not 20, maybe, so we'll see. There's a point where we probably will not be doing crewed aircraft, where we'll have, advanced satellites, advanced drones, advanced technology of all sorts. And honestly, from a safety standpoint, that does make sense. It's not happening today or tomorrow. I want to be very clear. But so this ConOp that we're talking about here, this one where we land launch, is probably going to be the core of the future for these types of observations. Deployed imagine right now, we just have the one deployment area of the Southwest Florida, but you could have on the Northern Gulf, you could have on the coast of Texas, North Carolina, the East Coast of Florida, up and down the East Coast. And then, as you said, with our Caribbean partners, forward deploy these things. So there's more logistics involved. You'd have to have it pre-deployed. You'd have to have a team that knows how to launch them. All that's doable, though. And I think it just takes resources and time. But that's the vision I think we're going to be looking at. That, and something else I haven't mentioned, is deploying things from the stratosphere, where we have these long duration drones that can drop microsondes. We're working on that too. And then potentially dirigibles, or large drones that can deploy drones into the system from aloft. So there's multiple ways we're attacking this problem.
Yeah, the 1 ouncers. So they're measuring all kinds of updraft and downdraft. There's no way they can penetrate those without effect.
Well, that's true. Actually, there's a couple of up sondes with the 8-ounce mini sonde, which is the standard drop sonde now. These things are half an ounce, so and not even an ounce, so 15 grams. And they do. We launched 20 of them in Raphael. Yeah, that's right, Raphael last year. The first time we swarmed them, 20 at once. And it was amazing because I can actually pull up a plot if you want later to show you. We dropped 20 in 1 minute. And what's amazing about that system, yes, they can get pulled up into go up, but they're still measuring, and you still can, eventually they come down. But we do get these where they get caught in updrafts and down, but they stay up longer, so you measure longer, and they cost half the price, Bill. So wow. These are the future, I think. And what's amazing about that one swarm we did in Raphael was, before you drop, you get a dropson and at the Hurricane Center and say, okay, this is what the eye wall looks like, right? Pressure, temperature, wind, humidity. No, that's not what you got. You're guessing. Think of it as an ensemble. Now what we're doing is we put 20 in there, and now we can give you an ensemble mean of what pressure, temperature, winds, and humidity are. So we were kind of flying blind before. When you get one drop in a dropson, maybe you get an extreme version of what that what the eye wall really was versus an actual understanding of looking at, say, the ensemble mean with the variance on each side. If I'm making sense, or I can explain that a little better, but yeah. We get more data really to understand what the reality is.
That's fascinating. Starlink, you don't have any problems with heavy rainfall attenuation in the signal?
So far, we only tested in clear air, but yeah, that is a concern that we have to worry about. But I think that it's still, we all use, I don't know if you realize it, when we fly transatlantic flights or even going across the country, and you put that video on, that movie you're watching, that's all Starlink. And so we do fly through weather in those cases. I need to do a little more digging on that, but I know that there's going to be some attenuation. But even if we have an occasional drop-offs, it's okay as long as we can get the signal back.
We can set up an experiment in my backyard, put a recording tipping bucket rain gauge in there and hook me up in Starlink, and I'll correlate the dropout in the signal with the rain, see if we have anything. I mean, that's one way to do it. I'm just joking about me because I'm not there half the time, but that'd be one way to test that out.
Yeah, and I guess I'm guessing, and I can reach out to the Starlink SpaceX folks. They should have, if they haven't done this testing on their own. It shouldn't be, us. But you're right. We're going to be in extreme weather with extreme rain rates, not just rain. So we have to look at that and see what's going on. We are excited about the possibility, keeping our fingers crossed, of we would only be able to go in the Gulf of Mexico for this system, for this platform, and the conditions have to be right. That 200-mile WRA, that ring around the center of the storm, has to intersect with that warning area I told you about. So there's a lot of stipulations to get us in a storm this year. But again, I always profess you got to crawl, walk, run. And right now we're crawling. But I would say even 6 months ago, we weren't even a zygote or an embryo. So we're happy to be crawling, actually.
Well, you've come a long way. When I left the Hurricane Center, I think you had a thing called Coyote that kind of worked sometimes and got here to a dropson was not very good. But the you guys that are forward thinkers kept convincing me this is the way to go, and I'm glad to see fruits of your labor. Hey, Hal, yeah, you look like you want to pick Joe's brain a little here before we hit the break.
Yeah, Joe, you talked about the advantage of drones, that you could fly so much lower than the P3s. So what elevation are these drones flying at, or are there a range of elevations?
So we deploy into the eye about 10,000 feet, because that's where the P3 is. And we quickly go down to about 5,000 feet. We have to have some separation between the P3 for safety. That's about 2,000 feet. But we want to use these drones to look at the lowest layers, right? So we kind of nosedive down to about 5,000. And then it depends on what we're doing. We have 3 modules with that S0. This is, again, going with the small drone now. And that we can do center fixing. Again, this is all AI. This is not someone with a joystick or anything like that. This is all using the sensors on the plane to determine where it's going. So it's all artificial intelligence and machine learning. So we have a center fix, which stays in the eye, and we get down very low to about 500 meters or less to get a really good hit on the center. The second one we is max wind finding, which is a fancy way of saying going in the eye wall and finding those max winds at different altitudes. So we might penetrate at 5,000, drop to 4, drop to 3, drop to 2, and keep going down. And eventually it goes in the water. But we've done eye wall penetration circumnavigation, which was a first. Last year we did that in Helene, first time ever. A drone went all the way around in one shot, and we were down about 150 meters. So that's pretty low, and we can go lower. The reason we don't go lower earlier is we can lose the plane. Remember, you got 60-foot waves down there, and there's a lot of downdrafts. One downdraft, you're done. So we do our most aggressive flying at high winds at low altitudes towards the end of the flight, maybe the last 20 minutes, so that we make sure we get enough obs. And we're sending these HD obs, which is just kind of a fancy format, averaging over a period the same way we get flight level from P3 data, identical. We send that to the Hurricane Center, constantly sending that. So these data are incredibly unique and incredibly valuable. I'm working with the Hurricane Center now to how do we adjust those down to 10 meters? Because that's the last question they've been giving us. And we're working on how to actually do that statistically, also using AI to come up with how we can reduce those winds to the actual values that the Hurricane Center wants.
Joe, you were sharing before about the record-setting duration of the work you're doing, but also these data collected from these lowest levels of the atmosphere, they have to be the lowest airborne data ever collected in tropical cyclones, right?
At those winds, yeah. And we're trying from a science, if I can dip into research a little bit, to those who look at the computer models, there are these transfer coefficients that are basically determining the flux, the energy coming out of the ocean, right? So momentum and energy, momentum from the storm to the surface, and also energy through evaporation coming out. And there's a lot of fudge factors going on there. Let's just be honest, okay? These parameterizations are guesses. And what we're using from the research standpoint is to directly measure the fluxes instead of these bulk parameters that use these drag coefficients and all these coefficients that the models are using now. We are using the direct measurements we're getting at low altitudes to collapse the uncertainty of those transfer coefficients. This is like holy grail type work.
That's amazing. You're taking theory and you're saying, actually, this is where the theory is working. Here's how we can tweak it. And you're really calibrating it with real world data.
Yes. And to my understanding, like you said, no one is getting low level, say 100 meter, 50 meter winds, 150 knots. We have a couple of situations in Milton where we had that. Nobody's getting that. Certainly not with an aircraft. Now, dropsondes can come down and give you a point, even though we really don't know exactly where that point is because there's some variability. We have a laser altimeter, and now we're working on a radar altimeter on the plane, so we can actually get the exact height. We have differential GPS, which gives us more accurate winds. So what we're doing is really cutting edge. I'm really proud of the team, and I'm proud of the persistence, myself and others, that, like Bill said, when we first started the version 1.0 of the Coyote, we're so far advanced from that now, and it's because we didn't give up, and we won't ever give up.
Joe, one last question before we go to our mid-show break. So you mentioned the value of adjusting the center of circulation when it's close to land, and all of a sudden that could tweak where this actually makes landfall. I could see there being advantages too, far from land, where maybe ensembles can say, oh, we're going to tweak our initial conditions, right? Because like you said, even if you're moving that center of circulation, maybe 15, 20 miles, that could play out a lot more than that down the road in the model, right?
100%. Yeah, I was just given probably the most extreme case where we're right at landfall or a day or two out of landfall. But yeah, there's no reason why we can't do this much more frequently. And, we've been doing these center fixes. The hurricane hunters have been doing this, Air Force and NOAA, forever, right? But let's be honest, they're flying at 8,000 and 10,000 feet. The storm is tilted, right? So they drop and they hope it gets, we want the center of circulation. We're going down to the bottom of the storm and getting the center of circulation. We're getting it, again, it's sort of like the fluxes, we're getting directly. Forget the drag coefficients. We're not going to guess. We're going to get it exact. Same thing. We're going to get the center because we're going to go actually down to the center. So these are observations that are, again, not like, oh, well, we'll get it some other way. You'll get an estimate some other way. You're not going to get it.
This is fantastic, and I can't wait to see how much this improves our forecasting. Tim, let's pass it over to you. I know you always love to share about our sponsors and all the wonderful people partnering with us at this time.
Yeah, so much going on. I don't want to interrupt this conversation because this is great. I'm just sitting back listening and enjoying it. We appreciate that. And Bill will get to your tropical update. But let's thank the sponsors very quickly before we do that, just so we can thank them for what they do to make these shows a possibility week in and week out. We start with USAA. We talk week in and week out about how important they are to what we're doing and all this information we're getting out there. We couldn't do it without USAA. They've been here from the beginning with the Storm Science Network and whatever we were before that, back from the days of doing conferences for kids. USAA was part of that, and we appreciate that, and a big sponsor of what we do. So
If I could jump in, I'm USAA member, and they have helped me tremendously. Our neighborhood was devastated by fires 3 years ago, and USAA came through big time. And me, my family, and some other folks that have USAA in my neighborhood are really appreciative of them. They've always been great.
we appreciate that. That's an endorsement beyond all. So thank you, Joe, for that very much. And thanks to USAA. South Padre Island Convention and Visitors Bureau. If you're a regular on this program, you know we meet there once a year. South Padre Island at the Marriott Courtyard Hotel. We'll be back there in April of 2026, and we hope you'll join us there as well. Always a lot of fun, and South Padre Island makes it possible for us to be there. So thank you for that. The Weather Company, that's the company that provides graphics for television stations around the nation and helps TV stations come up with those cool maps and charts that you see on TV to make the weather a little more understandable. Weather Boy, follow Weather Boy. Check them out, weatherboy.com, and they are really cool because they do scholarships for college students to come to the National Tropical Weather Conference, and college students from anywhere in the United States, including Hawaii, they sign up for a contest, and if they win, they get an all expenses paid trip to the National Tropical Weather Conference, where they not only learn from all the experts like Joe and Bill and Hal and everybody else that's there, but have the chance to sit down and have a one-on-one conversation with anybody at the conference they want to. Sit down, have lunch, whatever it is, and meet any of the experts that are there. So we appreciate that so very much for all that they do. And LiveView is the organization that makes sure that the local broadcast meteorologists who are at the National Tropical Weather Conference can do live shots, live broadcasts back to their home markets. And they're there to make that a possibility. We appreciate that very much as well. All right, Bill, it's seemingly quiet in the tropics right now, but maybe not so much. What have you got for us today?
Okay. I think you'll find this interesting. I thought when I was putting this together that I'd say it's all quiet for the next 7 days anywhere in the Western Hemisphere and turn it over to Hal for GeoTrek, but got to look at something and I'll see what you guys think about it once I get to it. All right, there's our 7-day outlook that's current, and it says just what I wanted to say, nothing expected. Same in the Eastern Pacific. After a wild start out there, the last two areas of interest in the possible formation fizzled out without forming, which lets people in Mexico rest a little bit after all the activity they've had there. On the satellite for the Eastern Pacific, there is some convection, but those of you that have been following this would realize that remember that there was a lot more concentration of convection south of Mexico and west of Central America through much of the last 6 weeks. That has changed, so that's a good thing. The Atlantic is what it's supposed to be in early July. A lot of dry air, not a lot of convection, no obvious African easterly waves of evident without really digging into it. This is a Tutlow up here. But the Gulf of Mexico, you probably heard some people have been tentatively suggesting out beyond this forecast period that we may see something try to form off this trough in here if the right order of convection gets in there. But right now, not even the highly imaginary sensitivity of the GFS picks up anything of consequence in there. But I want you to notice this disturbance down here. It's a mid to upper level disturbance that came across the southern Yucatan Peninsula into the southern Bay of Campeche and is now just offshore of eastern Mexico. And I did a quick look at it, and it doesn't develop. Obviously, it continues on its around the ridge path into Mexico. But then I got to looking at what it does after it comes inland, because that's kind of what led up to the floods and the contributor to the floods in Texas was what happened to the remnants of Barry after it came inland in a similar location. So this is yesterday, 18Z. There's a little hint of a vorticity center, a trophiness in the 700 millibar height field there. Okay, today, here it is. It's still kind of on the coast, but it's trekking slowly inland, and probably tonight into tomorrow will be the best chances for rain down your way, Tim. and then it just stops moving. That is never a good sign in a tropical atmosphere of stop moving because of the potential for very heavy rain. So I don't know if anything will come of it, but what we have is a troughiness still over West Texas and all this tropical moisture slowly feeding northward into it. No reason not to believe we're going to get heavy rain, heavy thunderstorms producing excessive rain rates. It's just way too far in advance to have a very good idea on just how much. Looking further down the road, remember a month ago, these were all blue colors. Some of the chill that had been going on in the tropical Atlantic has reversed itself. There's still a large area of slightly below normal temperatures just to on the north side of the main development region, but much of the tropical Atlantic has warmed back up. The Gulf stays where it's been forever, and you get this huge area of warm water in the subtropics up into the mid-latitudes. This is the 15-day change, and you can see that it's not been a lot of change, but it's been predominantly in the warming phase, which is not surprising being the peak insolation time of the year. Let's see what else I got here. There we go. Oh yeah, the other factor in our season has been the La Nada or neutral phase, and this is what a neutral phase looks like. No definitive large cool or large warm area along the El Nino zone in the Pacific. So with that, Hal, why don't you give us what you got on GeoTrek?
Yeah, Bill, thanks so much for the tropical weather update and some really interesting insights there about what we could potentially see. Reminding us that we don't necessarily need a named storm. Remnants of something can also be very catastrophic as well. Well, with GeoTrek, we explore the world to bring you stories about extreme weather and natural disasters not covered by the mainstream media. We're often in disaster zones, doing a lot of podcasting and weather communication. This last week for me was actually a database week. So another thing we do with GeoTrek, we actually run USurge, the U.S. Storm Surge database. We have high water marks for over 340 tropical cyclones that have impacted the U.S. since the mid-1800s. Well, I had some time this week. I'm in the Rocky Mountains, and I had some time to just really crunch data, and this is of interest. Looking back at last year's tropical cyclones along the Gulf, it was interesting to look at Hurricane Helene, a geographically huge storm that made landfall as a Cat 4 hurricane in Florida's Big Bend, producing storm surge all the way down to Tampa, St. Pete metro area. But it was interesting looking at the National Hurricane Center high water mark for Helene in Steinhatchee, Florida, 16.1 feet above normally dry ground. When we actually remove the tides from that, we're getting a preliminary storm surge of 17.58 feet. That's an estimate of how much salt water Helene actually pushed above where the water would have been if there was no storm. That's really inherently what storm surge is. The reason that's interesting, if that verifies, if our preliminary data verify, that actually places Helene as a top 10 U.S. storm surge going back to 1900. It would actually take the number 9th place. Hugo would move back to 10 and Rita would fall off the list. It's also the only the number 2 storm surge in Florida's history. The Labor Day hurricane of 1935 is the number 6 in U.S. history. So really interesting. A few take-home messages from that. We've known through slosh models and the great work that the National Hurricane Center has done that one of the most vulnerable areas in the U.S. to storm surge is that area north of Tampa, east of Apalachicola, kind of in that Appalachia Bay region where we have a concave-shaped coast, very shallow water. We've known theoretically you could get some of the highest storm surges in the U.S. in that area. It was interesting now to see that verify and see a top 10, what looks to be a top 10 storm surge in U.S. history with Helene last year. We'll continue crunching data, but at least preliminarily, it looks like Helene is now a top 10 storm surge in the U.S. A couple other things that we wanted to talk about. We have exciting podcasts coming up. We're going to have a podcast with Tom Little, the president and CEO of floodproofing.com. Our friend Jim Cantori, looks like we're going to do a podcast with him for the 20th anniversary of Hurricane Katrina coming up in August. But the catastrophe this last week in the Texas Hill Country, we absolutely want to cover this. We could actually use your help. We like to get on the ground. We like to do insightful podcasts that answer difficult questions. And if you can think of any angles with this, if there are questions you have about either the forecasting or communication or the complexity of what happened this past week with the catastrophic rains and flooding in Texas Hill Country. We'd love to hear from you. You can reach out to us at GeoTrek. That's GeoTrek. I'm on social media as Hurricane Hal. But again, we'd love to do an insightful podcast that really covers what happened, just such a catastrophic event, but something that we obviously all want to, improve forecasting and communication with weather events everywhere. We'd love to do a podcast on what happened in the Hill Country. We could use your help answering your questions or providing contacts for us. If you know of people that you think would have some really insightful perspectives, please reach out to us and let us know. That's everything we have from GeoTrek. Back to the broadcast now.
Thank you, Hal. We appreciate that. I love the GeoTrek podcast. Always great stuff. And I'm anxious to hear what you do in the Hill Country, because you'll be down there with the people, talking to the people and finding out what the experience was and really bringing it home for us. And we appreciate that. Let's just take a couple minutes and talk about that, because I don't think we can walk away from such a significant weather event that somewhat tropically connected. Bill, we were talking before the show about how, what could we have done better? As the weather enterprise, what could we have done better? I don't know. What do you think?
It could all, there's a lot of things that I think you're kind of second guessing doing it right away. I think you really need to do some very long thought process, looking at the data and seeing, is there anything in this data prior to the onset of the storm that should have triggered a different level of awareness on the risk? I don't know. I have no idea what was going on at the time. I'm up here in New Mexico, and I think a lot of the people that claiming they know that are jumping the gun on making a real assessment on the meteorology of it. That kind of rain is really a subject of probabilistic forecasting. We don't have, you know how to forecast a 20-inch rain, Tim?
Nope. It's going to happen somewhere.
A day in advance, for example, it doesn't happen. There's not. If you do, it's kind of luck. But they they look to me like they recognized the threat. They had the right area, and the warnings were timely with the onset of the rain and what they were getting in. Bigger problems for communication, which you guys can really help in, is how to get people to get the information and what format that information needs to be to get people who probably have no idea that those kind of floods could come there. They're from somewhere else when they're camping. How to get them to react and act in a timely fashion.
Well, we're hearing so much about people not getting messages on their phones, even though they've got things turned on. The NOAA weather radio, go back to that, but even at that, if you got the warning at 1 o'clock in the morning, if you'd gotten the warning when it was issued, is there time at that point, in that hill country area that is so, so susceptible to these problems? How much time do you need? And is that possible?
Yeah, that would have to be looked at, because I think from looking at the maps again, the roads getting you out of there to evacuate after the onset of the rain are down at river level. You want to send people out into the middle of a 3 to 4 inch an hour rainfall rate thunderstorm just to drive their car into the flood, or on the other hand, the other last refuge would be to go up the hillsides. You want to send kids out in the middle of a torrential thunderstorm, climbing up in the dark and rocky hills. Even those of us that know what's going on in here you're not going to react with instantly when you get those kind of warnings unless you're expecting it to happen.
Guys, one last question for me. I've had a lot of people ask me this week about NOAA Weather Radio. Do we have the same coverage and broadcast that we would have, say, 10 or 20 years ago before we saw a lot on our smartphones? I'm a little bit ignorant of it, and I was just wanting to reach out to everyone as a group.
Well, the Weather Service is still a part of their toolkit, and as best they can, keep them maintained and operating. I'm pretty sure there's one that reaches within the range of the hill country up there, but even back when we didn't have the cell phone technology, the amount of buy-in by general citizens was minuscule. We never found a good way to get widespread buy-in on the product.
Thanks, Bill. Appreciate it.
All right, we should get back to the subject at hand. We could talk about this all day. We could do 2 or 3 programs just on this, but we need to move back because we've got Joe, the expert here, on everything that's emerging, and we appreciate that. And how you forwarded some questions from, I believe, Casper, that I'll ask one of those now that kind of gets us back into it. I'm just going to read it, and it goes back into what you're talking about earlier, Joe. Has there been any evidence found that would contribute to the discovery of the structure of a strong tropical cyclone extending down to the ocean itself? There's a question from Casper.
You're muted, Joe.
You're muted. Joe, you're muted, I believe.
Yeah, you broke up right when the question, the last half. Can you just read it quick again?
Sure. Has there been any evidence found that would contribute to the discovery of the structure of a strong tropical cyclone extending down to the ocean itself?
Yeah, well, I mean, down to the ocean itself, I'm not sure what the questioner means by that, if that means below the surface or to the surface. So everything we measure is from within the boundary layer, at least from about 5,000 feet down, we're measuring with this emerging technology. With the stream sondes or the next generation, very light sondes, we're measuring from flight level, which is about 10,000. So, yeah, I mean, we use all the data that we get. And there's evidence. The evidence part is the hard part for me to answer. We're looking at it, obviously, from a research standpoint. We send that data in real time to the operational centers, so they're looking at it too. And I think what's unique about what we're doing is we're getting a concentrated amount of data in the lowest parts of the storm that we were not getting before. So hopefully that information is useful for nowcasting, meaning situational awareness, and also eventually getting that data into numerical models so that it can be used to help with the forecasts themselves.
Very good. Okay, go ahead. Hal, Bill, whoever wants to jump back in, go ahead. I've got others here, but I want you guys to get in.
Yeah, that I didn't quite understand Casper's question. I mean, to me, the evidence that it's a continuum. The storm doesn't just go away because there's an ocean there. If the very high seas and the dome of water you produce for storm surge is one piece of evidence that shows the connectivity. And then in the follow-on, if you get a satellite picture or a mapping of sea surface temperature, it leaves a cold track behind it. So there's the upwelling effect on that. And then, as Joe pointed out earlier, all the energy transfer issues that we're trying to get real science on it rather than having to parameterize it to give us a better answer how that impact goes. Joe, do you have any insight on the ocean type drones like the sail drone and underwater type drones that can be used?
So I've been again, my job is to look at all sorts of things. So we started the low hanging fruit, if you will, down in the boundary layer. We advanced up to look at better stream sondes, a better drop sonde system. And then we also looked at the stratosphere, which I touched on, that we'll have these drones that can stay up for weeks or months and drop these microsondes above the storm to give us maybe outflow dynamics and other things that are hard to get. But one of the areas is the ocean, right? So I don't know if your viewers have heard, but Saildrone's not going to be operating this year. There was some contractual issues having to do with, it's been an interesting year in NOAA. I'll leave it at that. So we've had some issues, and for whatever reason, Saildrone is not going to be operating this year. They've been operating the last several years. We do have gliders. We do have drifters that we put out into the storm. So these types of systems will still be there. I'm looking at the ocean too from our emerging tech angle. And there's a couple of companies that are very interesting. One is called SeaTrek, where they are profiling the atmosphere, sort of like an Alamo float. If you know what those are, there's bunches of Alamos, the technology that profiles in the ocean and then sends the data via satellite every once in a while. Emphasis on them once in a while. It's not every day per se. It's sometimes you can go as long as a week, I believe, and then the data is sent up. But the one I'm talking about is should be able to survive a hurricane environment and profiles much more rapidly. And interestingly, it uses the differential in the ocean temperatures and density to go up and down. So it's essentially harvesting and using free energy to do this. And it can last a lot longer, upwards of a year or more. So we have some new technology that we're looking at for the ocean, and we're really trying to look at how the ocean can modulate the intensity of these storms.
Yeah, there's still a lot of, I still see a lot of debate of just how the energy transfers take place. And the relative importance of differentiating between heat content and sea surface temperature. And it seems like this kind of data might help us solve that.
Yeah. I winced a little bit because I think, honestly, this is my own opinion. I think ocean heat content is overblown. It really, if you look at that number, it's a gigantic number, and it's basically the integral of energy down to 26 degrees. And it's you're taking the difference between giant number and how much flux is actually pulled out of the ocean, which is in relative to that giant number is a small number. So you're subtracting two giant numbers, and that's usually not the best way to go to see what the impact is. I think, to me, is looking at getting the initial conditions of the ocean out in the ambient before the hurricane gets there, right? And then running the computer models based on the forcing that the storm will enact on that system, and coming up with a final, if you will, sea surface temperature. And you got to be careful. Sea surface temperature in a mixed hurricane is actually the mixed layer temperature. It goes down to probably 30, 40 meters. So sometimes when people say skin temperature, SST, that's true when there's no winds. And the temperature is very different below that skin. But when you're in a hurricane, that sea surface temperature that you're measuring in a 100-mile-an-hour wind storm is actually well mixed already. Think of like when you were a kid, you made chocolate milk, right? So you mix the fluid in there. At first it's white, then it gets a little dark. Then eventually gets to chocolate milk, right? If you put the spoon in there and you keep mixing, it ain't gonna change. It's gonna stay the same. So that's the nice thing about the ocean. The densities are so different that the time scales of change are different. So once the ocean kind of sets up and you've got that fixed ocean under the storm, as long as the storm's moving, you've got a pretty good boundary condition. So it helps from a forecasting standpoint. Again, in my opinion, I think the ocean situation and the ocean predictability is a lot easier to handle than the atmosphere, which can change on minutes to hours to minutes, where you have convective time scales that can change everything. Downdrafts can change the boundary layer structure in a heartbeat, change the wind, the relative humidity, and that changes the fluxes. So the atmosphere is changing very quickly, and the ocean is important, but it's changing on inertial periods, which is many, many hours to days. So I think that helps us from a forecasting standpoint to pinpoint the impact of the ocean a little bit better than the atmosphere.
Interesting. I had not heard it explained that way before. I've pretty much subjectively have been on the same side of the coin as you are, because it doesn't seem to be a lot of correlation to be between what the hurricanes are doing and the heat content as compared to the sea surface temperature. But yeah, that's very, very good.
Joe, I had a question. What do we see as far as international collaboration, like these emerging technologies? Do we see them used in the Westpac? Do we see them down by Australia? Or, do we have stakeholders there saying, hey, we want to do what you're doing? Or do we also learn from them? What does the back and forth flux look like?
We're leading the charge. No, I'm not trying to, beat our chest on this, but there's, first of all, there's no one that does recon in the world, right? Think of that, just hurricane recon in general. So to get the advanced technology, you sort of need a recon platform, right? And we take advantage of that with the NOAA P3s. So we kind of have a built-in advantage. And then you got a team like ours that's super aggressive and doesn't give up. So we're making lots of progress there. And yes, the other basins are reaching out to us. They're saying, wait a minute, we want that. So initially 10 years ago, 15 years ago, I'm getting funded by some research that's done at the NOAA equivalent called KIOS, which is the Korean Institute for Ocean Technologies. And that's out in Busan, South Korea. So I've been funded and working with those collaborators for like a good 7-8 years. And initially they were like, hey, bring the P3s out or bring the Air Force. And I tried to do that, but that's a big ask because we only have 2 planes. And if you do that, then we don't have planes here. So it was a non-starter. We got close one year. But now though, it has changed because now we have balloons that go up into the stratosphere that then drift over hurricanes and drop microsondes over it. We also have that Dragoon system that I told you that can last for 20 hours and take off from Guam and get into typhoons and do that. I'm talking hypothetically. I haven't done this yet. So yeah, they're very interested, and I am working with them to try to figure out how do we do the funding aspect? How do we get the resources to do this? So we're on the cusp of doing this. I would say 26 will probably be the first year that we're going to try to dip our toe, particularly in the Westpac. Also, Jack Ellison, who's the CEO of Black Swift, this is the small drone that we dropped from the P3s. they in Barbados, I hooked them up because I know the director of the weather service there. And he's like, I see what you're doing too. We don't have the limitations that you do as much as from the regulation because it's FAA doesn't control the airspace there, and similar to the Westpac. And they said, we'll work with our regulators and let's start doing that. So the country of Barbados has bought a couple of these drones, and they're looking to use them as well. Maybe not just for hurricanes, but for fisheries, to do coastal mapping and things like that. But they have interest in doing hurricanes as well. So the international areas in the Caribbean, and I would say in the Westpac, I haven't reached out, or no one's reached out to me from Australia. I'm open to it if you got some connections. And I think the sky is and the waters and the ocean is the limit, really.
Joe, what about for the researchers watching the broadcast, the grad students who say, I want to do a master's thesis, I want to do a dissertation? With this topic of emerging technology, what are 2 or 3 main areas you would recommend they look into? Like, where are we going with this? Where's emerging research going with this?
Yeah. Reach out to me. First of all, we have a professor at Embry-Riddle who is taken a lot of undergraduates and brought them on the planes with us, flown them, done research. In fact, we just had the first paper published that looks at the low-level fluxes. Remember I said the drag coefficient, we can measure the flux directly? Well, now we have a paper that we just wrote in one of our testing flights, and an undergraduate wrote that. Now he's going to Notre Dame to do a master's. So, reach out to us as far as, getting your hands on some of the data. But I would talk to your professor. Let's say if you're going to Florida State or Penn State or my alma mater, NC State, go and say, listen, I want to be a grad student here, but I want to do the stuff that Sion and his team's doing down there. Can we work with them? And Gary Lackman is a good friend of mine, and I have a lot of connections all over the place. So if you're a student and you're in a school and you want to do something like this, talk to your potential advisors, and then reach out to me and we can work something out. We could either figure out how to get you on flights and work with the data, or just figure out the past data, what we have already. So we're building an archive. So there's a lot of opportunities to work with this data, and there's a lot of new areas that are really not understood well. As I said, I gave you one about trying to better understand those parameterization areas. But up at top of the atmosphere, we don't understand outflow all that great. We don't have a lot of observations besides some satellite stuff. And rapid intensification has always been a problem. It's still a problem. So there's a lot of things that we think. AI modeling. You hear about all this about AI models. I can tell you right now, they don't have our data. They're not training their AI models using our data. So whatever they're doing is not the full picture. So even there's advancements we can make in the AI field as well by training the data on our new stuff.
Thanks, Joe. Amazing perspectives. And I love your collaborative spirit there. Bill, Tim, I know we're getting short on time. I'll pass it back to you guys.
And Bill, go ahead and jump in with your final thoughts if you've got some.
Well, yeah, this is fascinating. Joe, you got my email address. I'd love to have a couple of what you would recommend as scientific papers on this whole idea so that I can forward it to a whole bunch of people that are interested in it.
Absolutely. I can give you my Vitae. It has I have all the latest papers that we're working on, and you can just pick and choose from there if you like.
Great.
Fascinating conversation, guys, and it's just love to see where we're headed. We've come a long way. It looks like, Joe, thanks to the work of you and your colleagues, we've come a long way, and we're jumping forward from this. The future is bright, I think, for what you guys are doing.
Yeah, I look forward to seeing you all next time. Couldn't make it through the conditions out of my control, but next conference, I definitely want to see you guys, and we'll have more stuff to share.
We'll make your reservation now, so you're all set. Hey, guys, while we've been talking, Dr. Klotzbach, who's not too far from you guys, the two of you there, updated his seasonal forecast, which he does today, and there it is. He's backed off 1 on the named storms, hurricanes in Category 3. The contributing factors are some shear in the Caribbean. The June-July shear in the Caribbean has been above normal, and that tends to cut down a little bit on storm activity, but we're still in sort of neutral. We still have warmer than normal Atlantic sea surface temperatures. Those two things point toward an above average season, but that shear, that kind of chops that off just a little bit. So he's backed off 1. He was at 17, 9, and 4 for named storms, hurricanes, and Cat 3s or higher. He's back to 16, 8-3. Does that make any difference in how we prepare? I hope not. Shouldn't make any difference whatsoever. We should still prepare regardless.
I'd still say Hal, Tim, and Bill are going to get busy someday this summer.
I don't really want to hear that, but yeah, I think
Alex has already been busy with the Hill Country.
Exactly. Guys, thank you. Great program. Hal, good job with your questions as always. We appreciate it.
Yeah, thank you so much. Great job, Joe. Amazing innovations that y'all are doing. Keep up the great work.
Thank
Bill,
you.
thanks.
Yeah. Thanks for having me.
Bill, thanks for the insight. Great questions as always, and the discussion about what happened in Texas this week. And Joe, thank you. Great program today. We really appreciate it. We look forward to what you've got coming out in the future.
Absolutely. Thanks again, guys. Appreciate it.
All right, let's thank our sponsors who make today's program a possibility. Once again, USAA, South Padre Island Convention and Visitors Bureau, the Weather Company, Weather Boy, and LiveView. They are the ones that make it so we can do this week in and week out throughout the hurricane season. That wraps it up for season 6, episode 6. Next week, Jason Dunyan will be with us. We're going to talk about the Saharan air layer because it is out there. It's thick. I can see it out my window right now. And so we're going to talk about that next week. So we hope you'll join us for that. In the meantime, take care. Have a great week. We'll talk to you next week.
Take care.